Hello, how's it going? Hope you're doing well. Welcome back to part two of the hands-on web development with Django course. And if you remember in the last course, what we did was we started up our Django project and we were also able to run a server as well. Now in today's course, what we're going to go over is apps within Django and also a little bit of SQL and data modeling. And so we can head on over to that now. Now, if you remember in our last video, what we did was we created a Django project. And you can think of a project as the whole site in its entirety. And if you remember, what it contains is a URL configuration file and also settings. But what it doesn't contain is a place to put views, models, and even templates. Now, where do we get those from? So in our case, what we have to do is we have to install an app into our Django project. And here we go. We install an app, and we'll just call it app number 1 in this case. Now, this app is going to contain models, views, and it's also going to contain its very own URL configuration file as well. Now, say in the future we want another application, another feature to our project and to our website, we can add that as well. Now, as you see in this case, we have two applications. They have their own models, views, and they have their own respective URL configuration as well. Now, let's think of a simple example where we have two applications, one for handling books and another for handling movies. And for some reason, you split this up into two separate applications because they work a little bit differently. Now, in our case, what you will do from here is if I just switch these around, what you can do is you can make the URL configuration file point to the URL configuration of the applications. And now let's see what this is going to look like at the URL configuration level. So here we have our top level URL configuration for our project. And as you remember, it had the admin path. And let's say we have two more paths, one for books and one for movies. Now, whenever the user redirects to the books path in their URL, it's going to head on over and look for all the URLs within the books URL configuration file. Now, same with movies. If in the user's browser they had domain.com/movies, anything after this is going to be redirected to the URL configuration for movies. Now we can go through a simple example on how this is going to work within the Django backend. So say within the user's browser, they type in our domain/movies/all movies. Now what's going to happen is Django is going to cut off this domain and it's going to start searching for URLs. So we go to admin, that doesn't work. It's going to look at books, it's going to work. And we're going to go to movies and we have a match. Now at this point, what we do is we cut this off from here, and then we pattern match around the URL configuration for movies. So we'll look here, all movies, that's a hit. And then what we can do is send that request back to the client, which is the user in our case. So in our case, because our application is going to be simple, we're only going to have a single application. And what we can do is, instead of having the books path, we're going to set this path as just an empty string. And so everything is going to be just sent over to the URL configuration for the books. And so what this will look like in this diagram is we're just going to have our books app like that. And so that's what our project is going to look like. And now we can head on over to VS Code and start coding that up. So now that we're on our Django project, you see that we have the outer my site directory and the inner my site directory. In here, we're going to go in, new terminal. So over here, we're just going to do ls, and we're going to see where we're at. We see we're at the outer directory, and we want to do cd. We want to change directory to the my site directory like that. And now if we do ls again, we see the manage.py file right here, and that's where we want to be because we're going to be doing a manage.py command. In this case, what we do is py manage.py start apps, and we're going to name it books like that. And so if you see here on the top left, we have the books app created for us. Now let's check this out. Within this books app, we have our admin.py. We'll talk about that later. Our apps.py file is just for configuration, and we're going to see that later as well. Here we have our models.py. This is where we're going to create our tables or models. We can write tests in our test.py, and we also have views.py. Now, generally for your views, for every URL path you have in your URL configuration, it's going to have a view assigned to it. So let's create a simple view and then let's assign it to a URL configuration. Now, before creating the view, I kind of want to just go back to the basics of what we're doing here. So in our case, we have a client, right? Or you can think of this as the browser. Now, the client sends a request to the server, right? In this case, this is Django. Now, what Django is going to do is it's going to send back a response, like so. And now this is the general pattern, right? We send a request to Django, and Django is going to send a response. And now this is what our view is going to model. Our view is going to model the request coming in, and it's also going to return a response as well. So in our case, let's just write down what we're going to do, right? So create a function. Let me just create a function that takes in a request. Do nothing with the request. For now, we're not going to do anything for it. Return a string to the client. So now we're going to create a function called index. And that's going to be the index page for our website. And this index function is going to take in a request, like so. For now, we're not going to do anything with the request, and then we're going to return a string back to the client. Now, you may be tempted to just simply do this, but in this case, it won't work. Now, the reason this won't work is because when we're sending back data to the client, we need to encapsulate that data within an HTTP response format. And so for something simple like this, what we can do is import from Django.http. We're going to import HTTP response, like so. So instead of returning the string, what we're going to do is do HTTP response hello, and then we can just add in hello world, like so. Now we need a URL configuration for the books application, right? And we don't see any, and that's because we need to add it in ourselves. So in our case, we go add a new file, urls.py. Now for a urls.py file, we need to first have an array called URL patterns, like so. Now we need to import the path function. So from Django.urls, import path. So now that we imported our path, we also need to import the view function right here. So we created the view function in the view file. So in this case, we can do from dots. And what this dot means is the directory that this urls.py file is in. So from dot, we want to import views, like so. And now we can create a path. And so if you remember, it's just going to be a list of path functions. So we create a path. In this case, because it's an index, we're going to have it blank. And then what we can do is views dot index, like so. Now in this case, there's a third parameter we can provide to this path function, and that's going to be a name. And this name parameter is going to be helpful for when we're referencing this path in different files in the project. So in this case, we can just name it index, like so. Now that we have a URL configuration for books, we need to tie this configuration to our outer configuration within the My Site directory right here. Now within the outer URL configuration for My Site right here, we have one more thing we need to import from Django URLs, which is include. Now this include function allows us to include another URL configuration from a different app. And we do that by just referencing the app in its URL configuration directly, right? So what we can do is path, and then it's going to be empty string. And then what we can do is use the include function. And within the string, we provide the name of the app, dot, and then the URLs file, like so. And don't forget, because this is a list, we also need to have a comma right here, like so. now we can start up the app, and when we do this, it's also going to tell us if there's any errors that occur within the process. So let's do this. So py manage.py run server, and let's be on the lookout for any errors that occur. Okay, no errors occurred. Hopefully no errors occurred on your end as well, but we do have the site running, as you can see on this URL. So let's head on over to that. Oh, I might have closed the server. Okay. And there we go. Hello world right there. And if you remember, this hello world is coming directly from within the books app right here. So hello world, this is books. And so what I'm going to do is, if I save this file, you're going to see down here, it's going to restart the server and then reapply those changes really quickly. So if we go back and then we refresh the page, there you go. This is books. Now we can play around with this URL configuration a little bit more, and just to get a better idea of it. So if you come to the outer URLs configuration, and then we add to this path the books, like so, and then we can see server restarted. Now when we refresh this page, it's going to error out because we don't really have a URL configuration for this empty index. There you go, page not found. You see it's tried admin and it's tried books, and there's nothing there. So in this case, we can add books, and there we go, it works. Hello world, this is books. Now we can drill down on this idea just a little bit more. So if we go to our books directory, and then urls.py, and then we name, and then we provide a new path. In this case, we'll just say all books, for example. And then views.all books, and then we can also give it a name, all books. Don't forget to add the comma like so. Now we have this all books path, and it references the all books function. Now we never created an all books function, and so if we try to join the server in its current form, oh, there we go. So it gives us an error when we try to run the server. Views.allbooks, module views.books.views has no attribute, all books, right? So if we go down to our views, we can add it. So we can do define all books, and then return HTTP response. This is all books page within books app. Now we save that. And so we have the regular books. And now if we join all books like so, this is the books, all books page within the books app. So there we go. And just to draw on this idea, right, what this looks like is this. So in our case, instead of empty string, we have books, and then we have all books like so. So in this section, we're going to talk about SQL, data storage, and data modeling. And I'm really excited to teach this. This is one of my favorite topics in computer science. And this really applies to everything that we use technology-wise. And whenever I experience or see systems in the real world, I always think to myself, how could I model this data? And so let's talk about that. So let's say you are a webmaster for a very popular website used all across the world. And this website is used simply for looking up phones and their manufacturers, right? And we need a database, a place to store all these phones across all the manufacturers. So let's think about that. How would you go about doing that? What would you use? What system would you use to store all that data? Now, if I really want to think of it in the simplest way possible, I think I would say a text file, right? Like a regular text file, something you may take notes in, right, while you're working. So in this database.txt files, I would just list out all the phones, and with each new phone being on a new line, right? So iPhone 17, the Pro Max, S25 Ultra, Pixels, and I would just store it all on this database.txt file. And whenever I want to add a new phone, right, I would just add it to a new line right here. So if I want to add a new phone right here, I would just add iPhone 15, for example. And so if we were to use Python, for example, we could read from and write to this database.txt file using just standard Python functions, right? So we open up the file and then we read it line by line over here in this section. And then if you wanted to add a new phone, what we could do is we can open the file and then we could add a phone on the new line over here. So in this case, there's an issue though. We only could store one piece of data for every line. So for example, for the iPhone 17, I would want to know what company it was made by, maybe what country it was assembled in, how long the battery life is, how good the screen is, how big the phone is, for example, maybe all this little details about it, right? And that's what we expect from web applications. So how do we fix that? How do we add more data to our database for every phone we have? And our database being this text file, in my case, we could go two directions, right? So we can go downwards. So let's say for every phone we allocated, three lines of space for maybe the manufacturer and the year and the country. Or what we could do is we can go horizontally this way in this case, and we could add the extra details there. Now, if you were to pick going horizontally and you were to also decide to split the data using commas, so if we do iPhone 17 and we do Apple and then maybe 2025, and then for example, what you just created is a CSV file, right, called comma separated values. And what this is used commonly is Excel spreadsheets. So this is kind of the data model that drives Excel. And in this case here, right, if we were to do it like this, a CSV file instead of a text file, we would first start off with a header line, right? And this header line is going to basically detail our columns, right? What columns do we have and what name are we going to provide it? And then for every row beneath it are going to be the individual rows in our database, right, in this table. And so you can see here, we can map this out to an Excel spreadsheet or a 2D table in this, two-dimensional table in this case. So for our web application, we were able to solve one problem, which was more data. And we were able to do that by taking our one-dimensional table and making it two-dimensional. Now, if we were to add more rows and more data to this table, if we were to grow larger and larger, would you be able to predict or see any future issues that could possibly arise from using this CSV file here for doing that? Now, just pause the video and think about that for a second. Now that you're done with that, let's ask two questions, right? What do you realize about the table? What if the table were to grow larger and larger? All right, what would you notice? And if this table did have a lot of rows, do you see an issue if Apple were to change its CEO? Right, so let's think about this, right? So for the first question, what if this table were to grow larger and larger? Meaning, what if we were to add a lot more rows? So maybe in 30 years, right, Apple came out with a couple hundred more phones, and maybe there's a couple hundred more phone manufacturers, and this and this Excel spreadsheet just gets longer and longer and longer. One thing that would happen is that there would be a lot of redundant data, right? So in this case, for Apple, right, we see that for the Apple manufacturer, we see that USA and that the year it was founded and then its CEO is replicated, right? And if this were to grow larger and larger, that's going to be a lot of data out there just for the same thing, right? So there might be 100, or maybe think about what if there are a million Apple phones out there? For all those rows, you're gonna have USA, 1976, and Tim Cook, right? And that's gonna be a lot of extra data to have in that database. Now, in that case, what if Apple were to change its CEO, right? Company CEOs change all the time. And if we were to have this really, really long spreadsheet as our database, and out of nowhere, Apple changed its CEO to somebody else, we would then have to go through that whole database, find where Apple is listed, and then manually change Tim Cook to the new CEO for every row on that database. And that would be a huge operation, right? Let's say the database was super big, right? Millions and millions and maybe even billions of rows long. And that sort of size is not uncommon for production databases, right? So, the solution, why limit yourself to only one table, right? Let's use multiple tables, right? So let's create two tables, one for phones and then one for manufacturers, right? So in this case, we have one table for phones that contains all the details related to the phone. And then we have a manufacturer table with all the details related to the manufacturer. Okay, so in its current form, what can we do so that every phone is related to its manufacturer? All right, so currently, we have every phone and then we have the manufacturers, but there's nothing that is connecting these two entities together, right? How am I supposed to know from this phone table, for example, how am I supposed to know from this phone table that Apple is the manufacturer and that it was founded in the USA and in 1976, right? How would I get that data? Let's think about that, right? Just think, what would you do to connect these two tables, right? So I'm gonna give you some hints as well. I won't leave you completely in the dark. Okay. So in this case, one hint is that we only need to modify a single table, right? We only need to change one table. We can do changes on one table and we can keep another table completely intact. We don't need to touch it, right? So that's one hint. Now a second hint is that we can only do a single modification, right? So, and that single modification is adding a single column. So we can only modify one table and we can only add a single column. Now, using that, what do you think we could do to relate these two entities together? Do I have another hint? Okay, here's another hint. Is there a way we can uniquely identify every row in the manufacturer table? So in this specific case, the manufacturer name is unique, right? Every manufacturer has a unique name, and there's no duplicate manufacturer names in this table. So what we can do is we can use that to identify every manufacturer on this table. And when we need information about a phone's manufacturer, we can look up that data using the manufacturer name. And so what we can do is we can add right here the manufacturer name as a field to the phone model. And what we can do now is now we know what manufacturer each phone comes from. And in the case that we want to have more data about the manufacturer, what we can do is just look up Apple in this table. And then we look up Apple, and then boom, we have all the data, the country where it was founded, and also its CEO. So now I want to talk about a little bit of the technical terminology when we do data modeling. And so one is the primary key. So because our manufacturer name is unique and is used to identify a single row in the table, that is called the primary key. Now, when we use a primary key in a different table as a reference, like we do in the phone table, right? So we use the manufacturer name field here. That's called a foreign key, right? So for this current configuration, is there any possible issues or problems that you think could arise, right? So in this case, we are using the manufacturer name as a primary key, And within the phone table, we're using that as a foreign key to reference the manufacturer. Now, let's start off with some hints, but before I get to the hints, pause the video and just try to think. And after every hint, pause again and see if you can figure it out, right? What's the issue that could possibly happen? And this isn't really a technical issue per se, but it's a real world issue, all right? So let's think, right? First issue. Remember, this is for a very popular website that tracks phones and manufacturers, right? So our data, in a sense, is going to model the real world. Now, the next hint is that new data is going to be constantly being added, right? New companies and new phones. Now, in the real world, can companies have the same name, right? So that brings me to the next slide, right? What if another company came out named Apple, right? And see right here. So in 2030, a Chinese company named Apple came out, and this would break our database model. Why? Because now, if I were to look at the iPhone 17 and I want to go and get the manufacturer data, this Apple manufacturer name now references two different fields. Now, because we're using the manufacturer name, if another company named Apple were to come out, it would create a problem in our database because we wouldn't know what Apple to refer to. Is it the Apple from the United States or the Apple from China, right? We wouldn't know that. Now, how would you fix this, right? What would you do in this current situation to fix this issue, right? The manufacturer name is not specific enough and it doesn't have it's not reliable enough to be a primary key. Now, one solution we have is to combine several fields together. And this solves a problem of non-unique keys. And in this case, what we would do is for our primary key, if we look at the manufacturer table over here, right? For our primary key, we would use two fields and combine it, right? So we would have a composite key. And our primary key would consist of both the name and the founded year. And when we then reference that composite key, we would reference both of those fields here in the phone table. In that way, we know that for the iPhone 17, we're talking about the Apple company that was founded in 1976, not the one that was founded in 2030. And so that is one way we can solve this. But what is another issue that could possibly arise in this current configuration? And I want to take you back to the previous note that our data is going to be bound by what happens in the real world, right? So think about what real world events could hurt our data integrity. What if Apple changed its name, right? Companies change their names from time to time. It doesn't happen often, but it certainly does happen. And in this case, if Apple were to change its name to, for example, Apple Tech, that would be an issue. What we would have to do then is then go to this phone table right here, and then we would have to then scan every single row and then fix it, right? And if we have a couple of phones, a couple hundred phones, it's no issue. But in production databases, when you have maybe millions or billions of rows, that is a huge issue, and that's something you don't want to do often. The fix for our primary key is indexes. The way we solve this is with indexes. Now, if you see on these two tables here, what we did is we added another field. And this field is called the ID field, right? And what we would do with this ID field is we would start at 1, and for every new row we add to the table, we would increment the ID field. So for one example, let's look at the manufacturer table down here. Now, if we wanted to add a new field to this, let's say we added Huawei, right? The phone company Huawei. If we added Huawei to this field, if we added Huawei to this table, we would then give Huawei an ID of 5. And if we added another company, say we added like Sony, then we would give that an ID of 6, right? And same goes for the phone table. And when we use IDs, it allows us to check mark all of the requirements you need to have a primary key. And so let's look at that, right? So in database design, generally, primary keys must be unique. They must be non-null, so they must always exist. They must be immutable, meaning they don't change, and they must be minimal, right? So it should be as minimal as possible. It should be as minimal as you can, right? And the only constraint for foreign keys is that they must reference a primary key, right? So that's important. And so instead of referencing fields like the name, the year, and other detailed fields of the entity, what we can do is just use an ID. And then every single row in that table could then be uniquely identified. And if we see here in the manufacturer field on the phone, we have numbers, right? So for the iPhone 17, we would see a manufacturer of 1. Now, 1 doesn't tell us much on its own, but if we reference 1 on the manufacturer table here, we can see then, okay, right, that's Apple from the United States, from founded in 1976 with Tim Cook as its CEO, right? And if another company named Apple were to come out, if Apple were to change its name, maybe if Apple were to change the country where it operates from, then we would be fine from any of those changes that happen, right? This next slide is just a bit of a warning, a bit of a heads up, right? So, me and you, as developers, we have an obligation to write secure code, and that is including you. If you're watching this video, you are a developer and you have an obligation to write secure code, right? Now, if you're doing local projects that are only going to run on your PC, right, and you're learning, right, that's fine. But if in the future, right, when you start writing code for production systems that real users all around the world are going to be able to access, these types of things are going to be very important. Okay, so the first thing is that we want to avoid exposing raw IDs within our URLs, our APIs. Then another thing is we want to always implement secure authorization for data requests. And in the case that you do need to expose some sort of primary key externally, right? There are different things that you could use. For example, you could use UUIDs or hashes. So that whole section was just a little bit about database design, why we use IDs, how we structure tables together to have relationships. And now we're going to talk a little bit about SQL. So SQL stands for Structured Query Language, and for relational databases, what you'll use most of the time, it's what we use to communicate with that database. And so that could be creating tables, fetching data, adding data, and so on and so forth. So SQL is a language just like JavaScript and Python is, but unlike Python and JavaScript, SQL is a single purpose language. And that purpose is to communicate with relational databases. Now, some examples of relational databases that you could use or that you may have heard of are MySQL, PostgreSQL, MariaDB, SQLite, and Oracle DB as well. And while SQL was largely the same between major SQL databases, they might have very slight syntax differences between them. So in the next 2 or 3 slides, I just want to give you some examples of what SQL looks like in its raw form, right? So in this red box right here, we have a create table, and we create a users table, right? And it has a ID integer that's auto incrementing and a name and email. Say we want to update an existing record within the database, we would use an update statement. So we would do update, and then we would use the name of the table, users, and then we would set the fields we want. So in this case, we're setting the email, and we're setting the email where ID is equal to 1. So in a case you want to insert new data into the table, we would look at this kind of orange yellow box. And so this is an insert statement. And so you would insert into users. We're going to insert an ID, name, and email. And then we provide these values like so. We then have a delete statement. So we would delete from users and then where ID is equal to 1. And then these two down here are select statements. So we're now pulling data from the database, right? So in the first one, we're going to say, I want to pull just the names from the users table. And on the second one, we use this star. And this means that select all the fields from users, right? And here are a couple different ones, right? So create table users, and then create table orders. And then in this case, what we're doing between these two tables is we're now connecting them via a foreign key relationship. So right here, we have the users table, and then we have a user ID, which is its primary key. And then within the orders table, so we have users on a website and they make an order, right? And within the within the orders table, we also include a user ID field. And then we say in the bottom here, we set a foreign key, and we say that this user ID references the user ID within the users table. Now you could also use a bit of a different syntax for creating foreign key reference, and this is just a little bit different, but you give a name of a constraint. So you give a name to the, pardon me, so you give a name to the constraint, and then you say foreign key user ID references user ID fields from the users table, and then we also have a on delete cascade statement. So this on delete cascade means that if we were to delete the users table, that we're going to also cascade those down to the orders table. So wherever this user ID is referenced, it will also delete orders where that user ID is also referenced as well. So in this slide, I kind of wanted to show how complicated some select statements could get. So when you want to pull data from two different tables, what you use is a join statement. Now on this blue square I have over here, this blue rectangle, pardon me, I have a simple join, right? So I select the user's name and the total of their order from users, and then I join the orders table where the user ID is equal to the user ID within the orders table. So on this green rectangle, we have a bit of a more complicated select statement. In this case, we're actually pulling from three different tables, right? So if we're pulling from an orders table, a users table, and a products table, we have some calculated fields. We have a where clause, a group by clause. We're ordering it by the total, and we also have a having clause as well here. Now, as far as communicating with a database, you have several options, right? So as far as desktop applications go, the two most popular databases, MySQL and PostgreSQL, have desktop applications, right? So for MySQL, you have MySQL Workbench, right? That's what it looks like here. And for PostgreSQL, we have pgadmin. That's what it looks like here. And in this case, what you could do is you can actually do select statements. You could look at tables. You could run queries, and then you could view the data, right? And you could also do it through a shell environment. So in this case, you're opening up your terminal and you're connecting through there. Or what you could do is kind of like what we're going to do in the future. We're going to do it directly through our code, right? So we import a package. So this is a piece of Python code here. So we import a package that's going to help us connect to the MySQL database, and we create a connection using the MySQL package here, .connector.connect. We connect using some information, and then we create a cursor. And then what we can do with that cursor is then execute queries. So we're going to select ID and name from users. And then from that, we're going to fetch all. And then we're going to print out those rows into the console. Now, down here, I want to talk about NoSQL databases. So this would be maybe MongoDB or maybe Cassandra. Now, with some caveats, SQL databases are used by every major technology company, right? Now, while they may be popular free tier solutions, NoSQL databases like MongoDB are never used as direct replacements to SQL databases. And building on that point, NoSQL databases only work well for very specific use cases. So while MongoDB might be pretty popular, it's not used as often as you may think. So within our application, within our Django framework, how do we communicate with the database, right? Now, in Django, we use a programming model and term called an ORM, right? And an ORM stands for an object relational mapping. Now, if we look at the diagram that I created here on the right side, right, we have the database here in blue, and what we can see is that the ORM is kind of a middleman between our database and our application. Now, the way ORMs do this is that they convert, in a way, database tables to objects within the programming language you are using, right? So that would be a class in Python, for example. And some examples of different ORMs that you may use or see are SQL Alchemy and Django ORM. Of course, that's what we're using for this tutorial. For JavaScript and TypeScript, you may use Drizzle or Prisma. And for Java, you may use something called Hibernate. Now, in a simple explanation, ORMs help to convert between types, columns, and tables in your database to types and objects within your programming language. So instead of creating a table and selecting with SQL like this, we do it using the Django ORM and we do it in Python, right? So what we can do is we can create a table using a class, and that we can then reference that class anywhere else in our application, and we can do operations on that very easily. So what we can do is that to get our users, in this case, what we would do is we would reference the users table, and then we would run a method on it. So .objects.all would return all of the fields of that table. So then after that, what it's going to do is it's going to populate that data into this user's variable right here. Now, if you are a little bit confused, I know it's a lot to take in, but just bear with me when we do this in our application and work with these databases within our view, in our model, and then later on in our template. It's all going to come together very nicely. So be confident, don't worry. And I was definitely very confused the first time doing this as well. So I'm going to stop the video here as it's getting pretty long. We'll continue on the next video by actually creating these models in our application and also creating some views as well to be able to display that data. And if you've gotten this far, congratulations. Thank you so much for sticking with me. I apologize for the patchy upload schedule. But other than that, I hope to see you in the next video, and thank you so much for watching.